Good morning, Fancy Meat Computers. How's everybody today? Looks like it's a nice, crisp autumn day out there today. Wonderful. Yes. So, I just want to, say that my email backlog is, pretty deep. Despite the fact that I had my email caught up last night. So if you sent me an email, it'll probably take me a fair amount of time this morning to get through it. So please don't don't expect miracles. Live system is always an option. Yeah. Oop. Good. Glad to hear that people are doing well. So, today we're going to do the last little bit of exceptions and exception handling. Fortunately, exception handling is, stupid easy. Really, it's very, very simple. And, nobody ever has any problem with it whatsoever at any time. So today, primarily, we're going to be talking about classes. Not this class, but classes in general, which is a very, very, very important part of object-oriented programming. Did I get my PhD from Mac? I am still doing my PhD, and it is, yes, I'm doing it at McMaster. McMaster is the institution I have called home for a very long time. I did my bachelor's degree here as well. Let's see. We'll just wait for a few people to show up. A few more people to show up. If this were an in-person lecture, I wouldn't wait for people to show up, But people sort of filter in. What's my thesis about? Oh my gosh. What even is my thesis about? Question of the hour. You want to see it? You can see how the folder's name is in all caps there. Thesis. There we go. Thesis. Don't let the page count fool you. That it's mostly code appendices that contribute to that. But that's way too small. So the thesis title I'm working on the title page at the moment. Applications of formal hardware modeling using BSV into PVS. Is PhD like postgraduate? No, you're still a graduate student if you're a PhD. Similarly to if you're a master's student, you're just like, it's like the difference between being a mage and being an archmage. You know, you're just kind of a higher ranked grad student. No, a postdoc is something you get after you have a PhD. So postdocs have to have a PhD. That's why they're called postdoc, right? Yeah. Did I do a master's? I actually transferred from the master's program into the PhD program here at McMaster. And, you know, if I had it all to do over again, I probably would have just finished it. Finished the master's before I did the PhD, but you know, hindsight's 20/20. There, if you want to screen cap the first half of the abstract, there you go. If you want to screen cap the second half of the abstract, there you go. If you want to read through that on your own time, if you can understand it, then you'll have some kind of rough idea of what my PhD's about. So. Yeah. Ugh. All right. So we should swiftly move on because we've got a lot of material to cover and not a lot of time to cover it in. So let's get it rolling, my friends. Get it rolling. So, exceptions. We were talking about exceptions last time. We were motivating exceptions, but we hadn't really gotten into the syntax. So I need a terminal. Terminal. Don't terminate the terminal. Actually, do I still need that? Oh, that's kind of fun. Can I do that and then pop it in and out? Nah, it doesn't work twice. Okay, but can I do this in full screen mode? That's the real question. I can! Hey, ho. Alright, so. Python 3. Oh my god. It's going to be that kind of a morning. There we go. So, as we said last time, Python has an inbuilt mechanism for handling values that really you shouldn't have to worry about. That's one way of thinking about it. It's like, if you're trying to do something that's incorrect, you will end up with an exception. Like, for example, if you try to integer convert the word katamari damasi, you will get a value error. It'll be like, nah. That's a Katamari joke. So, the value error that is raised, invalid literal for integer conversion with base 10, Katamari Damacy. Interestingly, though, I think that if you expand this to not quite, I think probably because it has a Y in it. Maybe? Yeah, anyway. You can, like, interpret it as hexadecimal. Yeah, there you go. You can actually, you can integer convert it. You just need to not have any invalid characters, and you need to specify this base system goes up to X, and that includes all the letters. But that's not really what you mean to do when you integer convert a word like that. I wonder if Y would work. Nope. It's too big. So, anyway. So errors are the types, like, we've been thinking about them as errors, but really we should be thinking about them as exceptions. And there is a subtle but non-trivial difference between exceptions and errors when you start getting into the nuts and bolts of how computer programmers, or how computer languages work. So, if you want to create your own exception, if you want to raise an exception, you simply use the raise keyword and specify the type of exception that you want to raise. So, for example, a value error. Bing, bang, boom. You can insert this into any point in your code the same way that you would insert anything else. It has an effect that's pretty similar to a return statement, actually, because when you raise an exception, the program halts, like that function that the exception raised, the function that the exception was raised in will terminate its execution, and unless the exception is handled, it will crash your program. Well, it'll cause a unplanned termination state, shall we say? But so this is all good. This can actually be useful. So what do I mean when I say handled versus unhandled? Well, we know how to do that. We know how to do that. So we have what's called a try-except block. So within the context of a program, you can just kind of throw these in anywhere. You can say try you know what? Actually, I'm going to do this in a file. So, let's say we take an input. Please enter an integer. Try n is equal to integer convert the results stored in x. Then, if that succeeds, print you entered the number x, except print what the frig, man? I asked. I clearly asked for an integer. Frig. There we go. So, because like the easiest way to explain this is to just do it, right? And show you what it looks like. Keep messing my shortcuts up. Anyway. So if I execute topic set. There we go. Please enter an integer. 7. You entered the number 7. Please enter an integer. Pokemon. Because I'm obsessed with Pokemon right now. What the frig, man? I clearly asked for an integer. Frig. So the point of this demonstration, as we've just demonstrated, this guy would fail out on an exception if I entered a non-integer value and then tried to integer convert it. So it's not that the exception isn't happening. It is happening. It's just getting caught because it's been sandboxed by the try block, right? So if an exception happens inside of a try block, what happens is that the code inside of the try block immediately terminates, and we jump to the accept block. And then once we execute the accept block, we can, do the rest of the program normally. Seven, yes, and Python. There you go. So it's a little bit like an if statement, it's a little bit like an if-else statement, except the thing that you're waiting for is you're telling the program, okay, stop, watch these statements, see if there's an exception that's raised, and if there is, don't crash the program, run this stuff instead. So this does not crash the program. Correct! Because the exception has been handled. What's the Windows command shortcut for getting all the files in a directory? Is it Control A? Control A with the thing in focus. Are the grades for assignment 5 out yet? No, I don't think so. Maybe, possibly. Quick word on test 1. At the request of one or two of your esteemed colleagues, I instructed the TAs to rearrange the test cases that they had so that they were a bit more generous with the part marks. That is, break the test. Like, they had some test cases that actually had multiple tests in them, and if you failed on any one of the tests, you would lose like 2 points, rather than, have a certain amount for each one of those test cases. So, by splitting those test cases up into their own test cells, and not changing the grade, not changing the amount of marks that the questions are worth in total, that actually had the effect of raising the grade point average on the entire test by 5 points, from a approximately 73% to approximately 78%. And don't believe the average that's posted on Avenue unless you know enough to do the zero. I always whenever I calculate the average, I leave out the zeros. So, yeah. There you go. Does accept catch any exception, or can you handle different ones separately? Good question. You can actually catch different types of errors by specifying them in the accept block. Come on. There we go. So for example, if you want to catch a value error, I'll just whip up another quick scenario for you. The inverse of that number is 1 divided by x. So those of you who are astute will have noticed that this line of code introduces the possibility of a zero division error. Except, I think it's called a zero division error. Let me just produce one quickly. Python 3. Zero division error. Print congrats, you broke the universe. So, there we go. So if we execute the thing now, if we enter 7, unsupported. What? I've got a different type. I've got a type error now, but that's my fault, not the fault of the input. Let's see. N. I should be using N. Good golly. There we go. See, a better programming language would not have allowed me to get away with that for so long. So, the inverse of 7 is 0.14. The inverse of 0 is congrats, you broke the universe. Ta-da! However, we've maintained that ability while also maintaining the ability to grumpy professor. While we still maintain the ability to like match the value error that might be raised as well. So there you go. What is accept exception? So it's kind of like, well, I guess you guys don't know what a case and what a switch case is, but basically whichever type of error is raised inside of the try block, you can catch that specific type of error by specifying it, and then you can also catch like every other type of error other than the ones that you've specifically specified by saying print tomb of the unknown error. So, yeah, A5 was due it was due Sunday, so there will be people with MSAFs that still have until Thursday to submit. Thursday? Wednesday? Today is Wednesday. So Thursday the grades should be coming out. But, yeah. So that's how you handle exceptions, generally speaking. You can raise exceptions in your code if it enters a situation your code isn't intended to handle. Now, I'm not gonna say that like you should now wrap every single piece of code you write in try except blocks. That would be overkill. However, when you have an operation which has a strong possibility of failure, such as division is tricky in computing, especially if one of the things can be 0 at some point. You can now handle that. You can create an error. So here's a list of the common types of errors that you would encounter while programming. Number 1, an index error. Index errors happen when you try to access something, an index in a list that doesn't exist. Fairly simple, straightforward. I'm sure you've seen a number of them already. Type errors happen when a function or operator is applied to an object of an inappropriate type. So, as we saw, I'm gonna give you examples. So, if of an index error, if we have list 1, 2, 3, 4, and we try to access element 4, we get an index error because the largest index there is 3 because of 0 indexing, remember. So with a type error, you have to perform an invalid operation. So if we had our list and we wanted to divide it by 5, that's a type error because division isn't defined. We don't know what division means when you have a list as the first argument and a integer as the second argument. It doesn't make any sense. Value errors we've seen quite a bit of when a function or operator is applied to an object of the right type, but it's otherwise inappropriate for some reason. Generally speaking, in other languages, you may hear these called domain errors at some point. It's like the function was expecting a number greater than 0, and it didn't get a number greater than 0. That type of error is usually a value error. Not implemented error. This is kind of a fun one. You can just kind of stick that in if you haven't done that bit of the code yet. Obviously, that won't get you any marks. The recursion error, when you hit the maximum recursion depth, then you get a recursion error. Runtime error, some error occurred and isn't classified elsewhere, and zero division error, which I also demonstrated. Question: if Python reads past the past memory allocated for a list when you try accessing indexes outside of its range. Wait, that's C. Yes. Thank you. You're going to learn all about that if you take 1x C3 with me, but essentially C is kind of an interesting language because it doesn't really do anything for you. I always tell my students that in C there are no free lunches. And that's kind of true of life as well. If somebody's offering you a free lunch, it's probably because they want you to listen to something. So, or sell you something. Sometimes getting you to listen to something is trying to sell you something, but they're not trying to sell it to you in terms of you paying with money. They want to sell it to you in terms of you paying with your attention. Anyway. So yeah, in C, arrays, first of all, it's arrays, not lists. And second of all, there's no such thing as an out-of-bounds error. You hit an error if you exceed the memory that has been allocated to your entire program, but there's no checking to see if you're outside of the bounds of an array. But, yeah, can I explain what the max recursion depth error is? Like, what if we need our recursion to go over the max depth? Use a better programming language. If you need recursion at that depth, you should be using Haskell, generally speaking. The recursion depth is set at like 1,000, I think. But, yeah. Is C going to steal my lunch money in 1xC3? No, but you're going to have to remember to bring your lunch money. Question. You explained the type error with list division as the program not knowing what it means to divide a list by an integer. Is there any way we can define that, like divide list into n smaller lists? Yeah, sure. Like, as we're going to see when we get into classes, you can actually, you the programmer, can define what the division operator means for particular classes that you come up with. It's a little more difficult to overload the inbuilt ones, but not as difficult as it should be. So, yeah. Yeah, you can define it yourself. You can define it to mean whatever you want. Like, personally, my intuitive thing I would go to is like a map operation. Like, if you divide a list by 5, that should divide every element of the list by 5 and, like, keep it in the list. That's how I would interpret it. But, yeah, you can think of it as, like, dividing the list into 5 equal pieces as well. Although how you'd store them is another problem, you know? But, why are we using C instead of C++? Isn't C++ just, like, a better version of C? The reason that C is covered in 1xC3 is because you have a course in second year on operating systems that, as Dr. Call put it to me once, cavalierly assumes that the students already know C. And, like, for operating systems development, C is preferred to C++. C++, like, the thing about C, like, the reason that C is used is, first of all, the existing code base. C is a language that's literally 50 years old. Like, it was developed in 1972, right? So, many, many, many operating system routines are still done in C because C is one of the goddamn fastest languages that exist right now because there's no extra miscellaneous bullshit. C is a very no bullshit language. It's like you have direct access to the memory control, like to the memory control structure. Use it wisely. You know, there's no checking to see if this is this or checking to make sure the programmer didn't screw up. It's a very like it's got the same philosophy about it as Linux does. It's like read the manual, know what you're doing, and if you screw up, don't come crying to me. That's C's attitude towards life. And because it has that attitude, it's one of the fastest programming languages. So if you want something that runs like very, very quickly and efficiently, C is your language. But it's definitely programming without the safety rails up. So yeah. Yeah. You use Haskell. Can you change the recursion depth in Python? Yeah, you can. You can. It's an adjust. You can adjust that. You can set it deeper. You'll consume more memory though. Yeah, it's a sec. I believe the course code is 2GA3. Yeah. Yeah. Yeah, that's fun. Yeah. I'd say C++ is more complicated than C. I would wholeheartedly agree that C++ is more complicated than C. Not necessarily better. Well, again, it really depends on your application, right? So it's interesting, right? Because in C, like all C programs are also valid C++ programs. So what C++ does is it takes a whole hell of a lot of extra constructs and it packs it all into C, basically. So, like, I think how it works is if you've written a C++ program that would also compile as a C program, it will be as efficient as a C program. But if you start using C++ for the types of stuff C++ was designed for, which is like classes and file stream, and like, you know, streams and whatchamacallits, vectors, then you start introducing more and more, you know, fluff that you don't necessarily need if you come up with a C implementation. However, one of the reasons that C++ is still very much used is because as programming languages go, it is very, very fast. Like I had one student of mine who took a vision processing algorithm that was written in Python, did a direct translation of it into C++, 5 times faster. But yeah. Unity is C#, yeah. C# is more Java than it is C++, though, to be honest with you. Every time I Google what game a language is coded in, I see C++. So yeah, Unreal Engine uses C++. Generally speaking, when you're writing a video game, especially like a 3D video game, you require that level of 3D accelerate. Like, you need a fast language to be able to do all of those calculations quickly. So, generally speaking, C++ is still a pretty popular choice for despite the fact that it's 45 years old because it was developed a few years after C was developed. Something like that. Maybe it's 42 years old. Anyway. So, one last thing, and then we move on to classes. Assertions. So we know how to raise an exception by just calling out the exception name, but we can also raise exceptions by just setting a condition. If the condition is true, then no exception is raised, and if the condition is false, then an exception is raised. So, for example, assert that 1 is equal to 1. This is fine. 1 is equal to 1, so nothing bad happens. However, if you assert that 1 is equal to 0, you get an assertion error. So this, generally speaking, is how the test... You may have noticed these in the test cases for the assignments and whatnot. This is how the autograding software actually works. And I probably shouldn't tell you this because somebody's going to find a way to break it this way, but essentially how it works is we test to make sure that the results of your functions executing, you know, we're testing them to see that they are particular results, right? And we raise, if they're not the values that we expect, then we use an assert statement to raise an assertion error. Because the way that the Jupyter autograding system works is you have this test case, and if it executes without raising an exception, you're fine. You get the marks. If an exception is raised while that test case is being executed, you don't get the marks. That's how it tells whether or not to give you the marks for a test cell or not. So yeah, so there you go. All right. C# looks extremely similar to Java. Yes. Yes, it does. You'll find the differences are primarily that it follows like C# type nomenclature when it comes to like private classes and stuff. Unless people are idiots, I don't think anybody will, since apparently it's academic dishonesty. Did I use C++ in my puzzle game? No, I used C# because I did it in Unity. Yeah, there you go. Well, well, it's kind of funny, right? I mean, yeah, it is academic dishonesty, and, you know, yeah, like, cheating the autograder is academic dishonesty. I'm sorry, but, like, yeah, like, it's kind of like academic dishonesty, and it's difficult for me to be mad at it because you have to display more skill in programming to cheat the autograder for the course than ever is required from you by the course. So it's like, well, clearly you're an expert programmer, but it's still cheating, so I'm still going to get you for cheating. Yeah. C# is Microsoft's Java, and it is arguably better than Java. Yeah, like, I've said this about Java in the past. I'm not sure what Java's unique selling point is. Like, what's the USP for Java now? Because, like, it's kind of become a victim of its own success, you know? Like, everybody has been ripping off Java for, like, the last 30 years. So what does it do left? Like, what's left in Java that hasn't been ripped off and done better by somebody else, you know? You know, but it'll stick around for a while, and it's worth learning just for the existing code base. So, classes. What is a class? Not this class. Minecraft! Yes, Minecraft mods. That's the only reason Java still exists. Pardon me. Kotlin. Yeah, people have been recommending Kotlin to me. Yeah, we'll see. Maybe we can start teaching everybody Kotlin in first year, and then knock Python down a few pegs, huh? It'd be nice to have. It would be nice to be teaching you with a language that has a decent type system, you know? Anyway. So, let's talk about classes. Just very quickly, some very important proper null pointer handling. Yeah, no kidding. There are some very important things to know about classes for all of you people who are not, like, the people... Replace Haskell. No! Haskell is a good language. Stop it. Yeah. So, there are some things that, like, all of these people in the chat who are arguing about programming languages who already know what objects are. There's stuff that the rest of you need to know that's very important about this particular topic. We're going to talk about classes. That means we're talking about object-oriented programming, right? It's really, really, really crucially important if you want a job as a programmer to know how to manage your abstractions. And object-oriented programming is overwhelmingly the most popular way of managing large programs that's going to be expected it's going to be expected that you are fluent in object-oriented programming if you expect to ever get a job, right? So, yeah, there's, I think 1XD3, which, like, XD, am I right? Lols. Oh my god. So OOP is also object-oriented programming. So OOP, object-oriented programming, that's the acronym. Yeah, I think you do, like, Django and JavaScript in 1XD3, but yeah. Jesus. So, anyway, what was I talking about? What did I even say? What? God. All right, fine. You have your joke. Stop distracting me. All right. So, what is a class? A class is a way of packaging together data with functions. So you take some variables, you take some functions, you smack them together, you produce an object. That's what classes are. People got tilted hard because someone said GUI instead of the full name, like GUI. Oh. Oh, because I said OOP instead of OOP? Alright. Fine. Fine. But anyway, so, classes. It's important to note that in Python, Python is an object-oriented language, and everything in Python is an object or a class. So, for example, if I look up what the type of the number 3 is, you'll see it's class integer. Class integer. If I look up the type of stop talking about Evangelion, that's class string. If you have a list, that's class list. If you have the type of type, that's class type. Everything is a class. No, it's multi-paradigm. Shut up. It's not. It likes to pretend it is. You know what Python is? It's like Python is like a 7-year-old child wearing her mother's high heels and claiming to be a businesswoman. That's what Python is when it comes to functional programming. I'm sorry. Did I watch the new movie? No, I haven't. I watched it a long time ago. Anyway, because, it's super old now. So, anyway, still interesting to watch, though. So let's talk about exceptions. We just talked about exceptions. It might occur to you in our as we were talking about exceptions, it might be useful to be able to define your own type of exception, right? We've got this big list of exceptions, but what if we need one? What if we need one that hasn't been isn't in this list, right? Well, there are two options, right? I showed this to you briefly last class. If you have raise exception, this is a custom error message. There you go. That's So that's like a way to, like, you can replace the error message, but you can't change the type of exception that way. And in order to be able to like match, use a try except block to match over the different types of exceptions, basically you've got to sneak your new customized exception into this list, right? You have to make it a proper error. So this is how you do it. You use a class. So let me open up a new thing here. Topic 8.py. There we go. So class. We then pick the name for the new exception class because, of course, just like everything else is a class, the type of, for example, value error is class type. There you go. It's also a class. So, class third impact error. That's a reference for all of those people in the chat who are chatting about animes. Has to inherit from exception. So basically what we're doing is we're taking the existing exception class, we are relabeling it as a new class. If that happens, then if we try and raise this type of error, then we can actually match directly on it. So, is making a new exception type similar to making a subclass of the exception type? So it's like, no, it's I forget the nomenclature. It's a derived class, not a base. So exception would be in I only know the C++ terminology. In C++ terminology, exception is the base class, and third impact error would be the derived class. Yeah, this is inheritance. What does the parameter of the class do? So this specifies other classes for our new class to yoink data from. Basically, this guy is exactly equal to an exception. I've basically set it as taking everything that exception has and contributing nothing itself. So in that case, it's kind of like a politician. But yeah, so if I wanted this class to add different things, I would include stuff here. But because I'm just doing pass, it doesn't. It's just creating a new instance of the class that picks up everything from exception, renames it, and then you can just use it. Is that under the concept of inheritance? Yes, this is what inheritance is. But we're gonna have lots of examples of inheritance, so don't worry about it. So that's number one. Number two, the Harry Potters. Getting all our pop culture references in on today. So I'm going to talk about data policy. So what is data policy? Data policy is interface is one. Listen, let me get to it, okay? Just let me have this. Let me have this. I didn't make these slides, but I this is like a good slide set. So let me have this. So data structures, right? Let's imagine, just hypothetical scenario, you wanted to set up a data structure in Python to keep track of all of these fictional characters from a fictional book nobody likes. There are a number of ways. Why do they have so many relatives? Because if you read the books, there are so many children in that family. There's like 8 children in that family. That's why. The more important question is, like, why are they all the same age? Right? Why have they all been, like, why are they all, like, Miiverse people? Anyway. So, if you wanted to have, like, entries in this family tree as being data objects in Python, one way that you might consider to do this is using dictionaries, right? You would have, you know, a number of different people. They would each have a name, a set, a list of children, and a spouse. So, you know, that's one way of doing it. You know, by setting up a bunch of dictionaries, for example, in this manner, we have established a data policy. We have said, when we get a name as a variable, we expect it to have this field, we expect it to have this field, we expect it to have this field, right? There are things we expect it to have each time. And this is actually a really good thing. This is a good thing to do. However, did I run the custom exception program? No, I didn't. All right, I'll run it quickly. Only because you asked so nicely. Invalid syntax. Whack, whack. I forgot the colon. There you go. Ta-da! So it's like a tree. No, well, you can, like, it's a much more general structure. Classes are a much more general structure than trees. Like, trees can be done in classes, but classes cannot be done in trees. So classes are the more general data structure. So our data structures are just any of the data, like in a list or an integer, or are they more specific? Well, it's kind of exactly what you want it to be, right? It's like, as we're going to see, classes are a very, very general purpose tool. You can do pretty much anything you want with them. You can do hierarchical structures. You don't have to do hierarchical structures. But yeah. So, anyway. It's now 10:20. So, we're going to stop here. If you have any questions, please let me know and I will answer them. Isn't that a circular reference with the spouses of Harry P. and Ginny W? No. It's not a circle. It's not a circular reference. Well, it is in the sense that you have two data structures that refer to each other, and it might, like, that would run us into a problem if you were ever doing anything like recursing over spouse names, but you would never recurse over spouse names anyways, so it doesn't really matter. Can I explain linked lists? Ha! Yes, I could. All right, I'm going to explain linked lists. Here we go. Hold on to your butts, people, because I'm jumping into another course. Is it in this one? Yeah, okay. You want singly linked lists or doubly linked lists? Can you explain what the custom exception program does in a little more depth, if you don't mind? Is it basically just going to call whatever is an exception every time it's raised? Yeah, so, yeah, you know, the exception class is going to have a certain number of, like, things defined in it. All we're doing is we're borrowing them, right? It's like, you see that thing over there? I want to take that thing and convert it into, like, mostly... I want to take that, do maybe a couple of modifications to it, but there you go. That's what the concept of inheritance is. Oh, except... So, yeah. Oh, with try excepts. Yes. One more question about Python. So, let me open, get it, topic 7.py. Alright, so this is how it works. When you're inside a try block, you execute the statements, just the same as you would regularly. If an exception is raised while executing the statements, you skip the rest of this block and you jump immediately into whichever except case matches the type of error that you produced. So if it's a value error and you have a case for value errors, you do that. You can catch all types of exceptions by just not specifying which error you want to handle. And then it does that. It does whatever is in there, and then it continues on with the rest of the program as normal. And it doesn't crash. Normally it would crash. If you didn't use a try except, it would crash. Oh, what about the custom one? Yeah, it's just like, basically we've created a new value error, right? So it's like we took everything that, like value error derives itself in the same way that, from the exception base class, in the same way that we are deriving a new error from the base class. So this is the same way that value error is created. It's just a relabeling, right? Don't worry if you don't get it yet. We're going to talk about it, like, more. Hopefully you'll get it soon. So, anyway. So let's start with singly linked lists. So the problem with singly linked lists and talking about them now is that they kind of require you to know what a pointer is, which you won't, but this is your fault for asking for stuff that's not even in your course. So basically, what a linked list is it's a series of data nodes that contain data and also contain a reference to the next data node. So I've been, in this particular slide set, I'm like working up this example of like, I have a node that contains a name, an email, and a pinball high score. So, and it contains a pointer to the next node. So, this, this is basically like a different way. Python Tutor kind of gives the idea of what a pointer is. Yeah, you know Python Tutor has a ctutor mode? That's going to be very useful in WhatX C3. So, so why would you do it this way, right? What is the advantage of this over just holding the values in continuous memory, like, you know, a regular C array? Well, you can be guaranteed that the way that more advanced programming languages than C handle lists is using a data structure like this one. How it works is it improves your ability to expand or contract the list, right? Each one of these is a separate node in memory, which means its memory is managed separately from the rest of the list, right? So you can add a node by just plopping it down in memory, and you can insert it anywhere you like in the list, by, you know, take like the second element's pointer, point it to the newly created node, and then take the new pointer's node and point that to the thing that this guy was originally pointing to, right? So it means that you don't need big continuous memory chunks, which is advantageous. And, you know, it means that your list is stored, like, all over the place, zigzaggy in memory, but that's not usually a problem, actually. And the last element in the linked list usually points to null, or it has 0 for a pointer. So that's how it works. A doubly linked list is basically the same idea, except it's got a pointer for the next node, and it has a pointer for the previous node. So doubly linked means that it links itself twice, right? The reason that you would want to do this is that with a singly linked list, the problem with a singly linked list is that you can only go one direction, right? So if you know, for example, node 3, if you know where node 3 is, you can only access nodes 4, 5, and 6, and etc. onto the end of the list. It's impossible to get back to nodes 2 and 1. Whereas, with a doubly linked list, you can just follow the previous pointers back. So there you go. So that's what a doubly linked list is. What do you, yeah. So what do you think? Sounds like you might have a question. While you think of your question, I'm going to pull up the comic that I found about linked lists, which I think is funny. How would I iterate over a linked list as I would a list? Well, you're talking about traversal, right? It's easy. Hypothetically, you'll have the, you should have a reference to the first node in the list. That's typically what we think of as the list, right? And it's easy. You just dereference the pointer that's pointing to the next node, and that'll give you the next node. Just repeat that until you find that that pointer is null, and then you stop because you've reached the end of the list. You can do it recursively pretty easily as well. Generally speaking, once we start getting into these types of data algorithms, or data structures, you start to really want to have your recursion, like, you want recursion to be one of your primary problem-solving techniques by the time you're doing this type of problem, because it's easier to solve these types of problems with recursion than with an iterative solution. Cool. All right. If that's everything today, if there are no further questions, then I'm going to log off here. Thank you very much for being here and doing the learning thing, etc., etc. Is recursion implemented well in C like it is in Haskell? I would say no. C's implementation of recursion is not as good as Haskell's because Haskell has been optimized from the ground up specifically to optimize recursion because it uses recursion for literally everything. In C, when you do recursion, you have to open up a new stack frame for each function call that you make, so that's a lot of memory overhead. In Haskell, they managed to do that. Like, in Haskell, functions don't have state, so you don't really need a stack frame, right? But I'm not an expert in the manner in which Haskell has been optimized under the hood, because that is some high math right there. So if you're curious about that type of thing, I would refer you to Dr. Call. So C's is like Python. Yes. The way C does recursion is like the way that Python does recursion, for sure. In fact, a lot of the things that Python does are like the way C does things. Python is a C-based language. In fact, Python's syntax is fairly similar to how C works. All right. Peace out. Stay cozy.